Hi there, it's good to see you all again. Today, we're still in the topic of soil physical properties and we get more detail in soil structure. As previously, we already discussed about the soil particle distribution, which is the soil texture, and now we like to look at the arrangement among soil particles. And this is somehow the soil aggregate or the soil structural unit can be formed up. Start with the primary particles with stabilizing agents, and then you get aggregate. And from small aggregate will increase its size to larger aggregate, and this is somehow change the whole soil structure. So it's totally depend on the aggregate shapes that will form up the whole soil structure look like. In terms of the stabilizing agent, we can have like clay particles, humus, and iron oxide that I will get you guys in more detail according to the stabilizing agent. So basically, from the very basic primary particle forming up to small or micro aggregate size, and then increase the size up to macro aggregate size. So this is how the soil made up the structure. So the formation of the soil aggregate can be found according to physical processes, biological processes, and chemical processes. Here, freeze and thaw, it means that water can change volume according to the temperature. From freeze to thaw, that can have different pressure that can somehow change the soil structure, including the soil aggregate shape. Wetting and drying, this is really important, especially when you have typical clay mineral type of thing that can swell when it's wet and can shrink down when it dries, something like that. For root and some other microorganism that can produce some sort of a carbohydrate or polysaccharide substance that can help to hold up the soil particles together, forming up the aggregate. That would be also important as well. And for chemical processes, this is totally depend on the seasoning agent like clay, organic matter, iron and aluminum compounds, and also the basic cation like calcium and magnesium, and recently potassium would work for tropical soils as well. Now here, I like you guys to take a look on the level of formation started from clay particles individually start forming up together by electrostatic force according to the cation bridge. And here you see the size the cell is probably less than 0.002 millimeter or less than 2 micron. With this level forming up, you will get a clay domain. And once you have a lot more than one just clay domain, form up the cluster among clay. And with the source of cementing agent like organic matter, calcium carbonate, silicate, aluminum, and iron oxide can build up the bonding among cluster and sand and silt particle, and that will give you micro aggregate, and the size will be in a range of 0.02 to 0.25 millimeter. For microaggregate, again with the same approach, according to the cementing agent that can form up macroaggregate, and the size will be greater than 0.25 millimeter or above 250 micron in diameter. Aggregate is really important because it totally affects physical process in soil. You can see that this is really basic structure of the soil itself. So aggregate can make the pathway for air and water and some sort of solution flow in soil. So aggregation basically increase pore space, decrease soil density, and balance air and water in the root zone. So it's really important, especially when you grow plant that totally need air, right? Especially oxygen. So if you have no aggregation at all the particles probably stuck to each other and have no pore space at all. So that why you can have air flow into the soil, and eventually plant root will be lacking of oxygen, and that will suppress the growth and of course the yields of the plant itself. Soils with a stable aggregate have a better infiltration. That's happen because all the aggregate will have a wide range of pore size, and once the large pore size connect to each other, that will give a really good pathway for water can get through the soil surface. So this is good because if you have a lot of rain or heavy rain that go through the soil surface, but you didn't have stable aggregate, then you are tend to lose the soil according to water, and runoff situation will be happen. Soils with poor aggregate are more easily eroded by water and wind, and that's according to they have less amount of cementing agent that can hold the soil particle together as an aggregate. So it's really important to know your own soil aggregate status, so that way you can manage make them better in terms of structure, and kind of prevent from having the erosion activator like water and wind that campaign role, and then you keep losing your soil. Aggregate affects on carbon cycling as well by protecting carbon from microbial decomposition. This happens when the soil starting have an aggregate size that really small and have small pores that kind of even smaller than the size of the micro organism itself. So that way the microorganism cannot take advantage of that sort of carbon substance, so it kind of left in there, and then the soil itself can keep that carbon for a long time. We call them, in a word, of carbon sequestration. Now aggregate shapes. Aggregate shape is very fundamental story. Once you have different shapes in terms of aggregate shape, that will affect to the whole soil structure. Like you have a lot of spherical aggregates, and that will give you granular structure. But if that granular structure is already porous aggregate, like a lot of pores inside of the granular structure. But if you have very porous, a lot of pores in there, we call in different name as crumb structure. This is somehow that and I would say that really good structure that we like to have in our field for growing plant. Cube aggregate, this is somehow look like a blocky structure, and you have two different kind here. Subangular blocky and angular blocky. It totally depend on the sharp edge you have. Prism aggregate or prismatic structure. Here you have different height, and I'll show you the figure of it in the next few slides. Column aggregates. This is in a shape of columnar structure. Thin and sheet aggregate showing you the platy structure. So with all this in the red color here, this is the shape of structure that totally depend on the aggregate shapes different. Here how they look like, granular, porous, and crumb structure very porous here. This is blocky. You can have angular blocky and subangular blocky. You see that with angular blocky you have a lot more sharp edge there, and subangular you have less sharp edge here. And for column or stick structure, here you have columnar with the rounded top, and prismatic with the flat or angular top here. This is how they look different. And plate light, this is somehow look like sheets. This is just a clay particle that stack up each other and then give you a plate light kind of shape. Now you can see that these different structure, actually it's not like when you see the soil structure out there, you're not going to see all of it like in single shape. Most of the time you can see more than one aggregate shape in the field in soil profile. Like in this very typical that you will see the granular on the topsoil, and below the topsoil, you probably see some subangular blocky or angular blocky, and then you might see some sort of the clay stack according to the tillage, something like that. And below that, you will see the column structure, something like that. That could happen. We also have some sort of a structureless structure. This one is misspelling here, structure. Sorry for that. The single grain sand here, where you can see in all individual sand grain and the massive structure, or you actually have no structure at all. All the clay particles just stuck to each other. That's it, and water or air cannot pass through this type of soil structure. So both of these two, it's just really extreme case where you can have a lot of air for single grain, but have a very small amount of water here. But here you have a lot of water, but you have less of oxygen. So if you have some sort of this type of soil structure, you have to be considering on how you're gonna manage this type of soil that fit well with your plant. So basically, we choose the plant that fit well with this type of soil structure. That will be wise, and then you have less technology that you're going to use for that cropping system. Here's the table showing you the different size class according to the different aggregate shapes as well. So you can see that the size class is consisting of very fine, medium, coarse, and very coarse here. And the next column will be different shapes. The first one here is the granules or sphere. The next one is plate, and this one is block, and the last one is the prism or column. So the number here showing you the characteristic length. Like in terms of sphere, you have diameter. In terms of plate, you have thickness. In terms of block, also diameter, and column or prism also is going to be diameter as well. So from this table, it can help you identify what aggregate size you have, and then you can bring that information for better management. Next is aggregate grade. This is show you the structure strength or aggregate, how strong that you can see out there, and it's gonna be difficult or it's pretty easy to destroy this type of aggregate. So basically, aggregate grade is typical to see if that easy to see that kind of structure in the soil profile. How many of the primary particles are aggregated, or how strongly the primary particles are held together. So with all these three concepts, you can identify the aggregate grade in different way. The first of all, structureless. Structureless are no observable aggregation at all. Weak is difficult to see in the horizon, mostly not aggregated at all, and easily to break with the little handling. Moderate is can be seen in the horizon and mostly aggregated. Strong, it means that you can sure you will see in the piton, and mostly aggregated and not readily fall apart when handled. So we like to have such a strong aggregate grade, of course. Soil structure is really important as it can increase the infiltration according to the pore connected, and that will reduce runoff and erosion and increase available plant holding capacity. Because when we talk about the porous of the soil aggregate itself, it could be the size range from very small pore to large pore. Small pore is really important for hold the water, hold back from or hold against the gravity. That why the soil can hold a lot of water that available for plant growth. On the other hand, the large pore also important that when they're connected, that give you a pathway to drain water and let the air flow through the soil system. Soil structure can improve seeding emergence, root growth, and development, and that's according to the pathway I said that bring about the oxygen into the soil, and oxygen is really important for seeding emergence. Large continuous pore improve soil permeability, so that way soil can have water and air circulate in the soil system. Here this figure showing you guys 6 different soil structure that completely different according to the aggregate shapes you have. But once we categorize them in terms of water flow, you can have three groups here. The first of all is the single grain and granular. This is gonna be together, and once you have this type, either type of aggregate shape here, you are sure now that water will flow really fast in this case. Where the platy and massive structure here is just block the water and air flow into the soil system. You can see that all the soil particle, especially clay size particle, just stack up and just hold tightly to each other, where actually the force that they hold to each other is kind of like perpendicular to the water flow. So this somehow blocking the water flow direction as well. Also the massive structure. In terms of blocky, this is kind of between these two groups. So the water can flow just right in the middle, intermediate flow rate. So that somehow we know that soil structure is really important, and we need to maintain all the good thing and improve something that still in not good condition. So first of all, never till soil when it's too wet. It will make your soil become cloddy, and that is according to the breakdown of aggregate itself. So tillage is totally depend on the moisture condition. So make sure that it's not too wet, otherwise you will lose a lot of good structure. Proper lime and fertilizer application, this will help because you already give the really good basic cation and some sort of cementing agent. Grow some grass and legume in agricultural system. This way you have two different root length system, where grass is pretty short root and legume is deep root kind of plants, and then you can have a circulate of all substance into the soil system, and that kind of balance the cementing agent and everything, and make the soil aggregate very good in terms of structure. Legumes also give more soil microorganism to stabilize soil aggregate, because legume most of the time have its own microorganism that work together with its root, so that way you can have a lot more root exudates and all kind of polysaccharides, protein and everything that kind of help through the aggregate formation. Try to maintain or add a lot more organic matter into the plant root zone. Maybe grow some clover crops and grasses, turn undercrop residue back to the soil, add some more manure to the soil system as well. Because organic matter, you know that it's not just for being the cementing agents, but also that provide you a lot more wide range of pore size distribution into the soil system, so you can drain a lot of air you drain a lot of water while bring the air to the soil, and at the same time you will have a lot more small pores that can hold available water for plants as well. So that is pretty much all the soil structure. Hope you guys can get this information and then can apply into the field. We will make sure that you guys will have some sort of activity that you can bring this information to play in the class, and then got something that relevant that you can use for the future. Alright, see you guys again for the next clip video, and enjoy. Bye bye.